Okay, this is part 6 of the QGIS 2.10 tutorials, and in this one we're going to do something different. We're going to do a distance matrix between 2-point layers, and then we're going to do statistical summaries of a spatial join. So for this case, we're going to use a previously created file, which was a layer of railway stations in Taiwan that is projected into a projection that we want to use. So here's a bunch of railway stations in Taiwan, and I've opened them in the wrong encoding, so I'll redo that. It's not UTF-8, it's Big 5. Won't really matter, but I'll just show them to you in the correct form. So here they are, Big 5 railway stations. These should be okay. And so here's the railway stations, their names, and so on. And if we remove that, if we take a look at the projection, we will see that it's in the Xi'an 1980 Gauss-Kruger projection. So we basically want projected coordinate system in order to do this distance matrix calculation. So what do we want to calculate? We want to calculate actually a file of power plants. And that's from this data set called KARMA, which is a global data set of power plants. I'm going to open that. And now you can see that we have 75 power plants, and we basically want to know what are the 5 nearest railway stations to each power plant. So we've made sure that both of them are in the correct coordinate system, Xi'an 1980. They're both in the same coordinate system. So we should be able to run a analysis distance matrix. Now, we want the input layer to be the KARMA stations, and we want to make sure we get a unique ID. Each power plant has its own ID. And then the target is going to be the railway stations right here. And we want to make sure they have a unique ID, which is the station ID. Now, the output matrix, we basically want to only use the nearest 5 stations. Otherwise, the calculation can just go on forever. It can get quite complicated. But we just want to know what is the distance, the linear distance, in meters, that's the units of our projected coordinate space, to each of the nearest 5 stations for each power plant. Okay, so we'll output that. And we're just going to call that matrix 1. We're going to have a series of these because this will be a delimited text file output, because there's going to be more than one result for each point. So we'll say OK, and we actually created the file. It's quite fast, so it didn't really seem to be even creating anything, but we created it right here. We can look at it in a spreadsheet software, and we can see that each input ID, that's each power plant ID, was calculated to find the nearest 5 railway stations. So the closest one to this plant 7911 was 1,300 meters, 1.3 kilometers, and the farthest was 7.8 kilometers. Okay, so that's basically the data that we generated. Now that we have the tabular data file for that, we need to massage that data file in order to do a statistical summary. So the first thing we need to do is add that data file to our project, it has no coordinates in it, it only has distances, so we're just going to add it as a tabular data file. And now we need to join the XY coordinates back to it. So we want to join the XY coordinates that exist in the Karma power plant file to our matrix data based on the plant ID, which is the input ID. So basically taking all that power plant attribute table and joining it to our matrix table based on the plant ID. Apply, okay. So now when I look at my matrix file, I have a bunch more information than just the distance. I have the information for each of those power plants. So now I want to export this to a new CSV file. And the reason why it has to be a CSV file is because I'm trying to make use of those XY coordinates that I just joined. So I'm going to call this matrix 2. It's going to be a series of files. So I calculated the matrix. Now I'm exporting it to a new file called matrix 2, and there it is. So here I have it now. It's not joined in memory, it's a real file now. And I want to basically remove this, and I want to add it actually as a CSV file in order to project it as points. So now I'm using the add delimited text tool to bring matrix 2 in. There's matrix 2. And you see it's not tab delimited, there are commas in there. So the delimiters are right, and I just need to identify, make sure that it got the correct latitude and longitude values from those fields. And it said the X was longitude, that's right, and it said the Y was latitude, that's right. Okay, and the first record has field names, that's right. So I say OK, WGS 84, okay. So now I have this matrix 2 file, which basically, it's not just 75 plants, it's 375 rows, because each plant times 5. So I have it there as a in memory, and I need to save it out as a shapefile. In order to do some join operations, some geoprocessing, I need it to be a shapefile. So once more, I got a new version of the file just in this series of steps, matrix 3. Okay, and it's in WGS 84, which I don't really want. I want it to be in Xi'an 1980. The rest is okay. There it is. Take off matrix 2, remove it. Okay, so now I have a shapefile, and it has all 375 points stacked on top of each other. And now I really only want the distance values. As you can see, there's a whole bunch of fields here that I don't need. I only need the distance value now for my summary. So I'll go into Table Manager and just make my life easier, and I'll say, okay, the input ID, the target ID, the distance, but all these other fields that were in the join, I really don't need them. Save. Yes. So now the matrix shapefile only has the distances. It basically says there's a point in there that relates to Karma Station 7911, In fact, there's 5 points in there, and these are their distances. So now I have 2 shapefiles in my project, and they're both in the same projection. So now I should be able to actually get the summary. And the way I do that is I do a vector data management join by attribute, join attribute by location. So I'm basically saying, join based on the point these 2 files. So the target is I'm bringing it to the power plant, and I want to figure out what the mean distance is to each one of these 5 stations in matrix 3. So in order to do that, I want to take a summary of all of those. In other words, for those 5 different distances to each plant, I want the mean value of the distance in meters, because that's the unit of that it's projected in. So now I can actually get my matrix mean. And that's sort of what I was trying to get the whole time. And I can say OK and add it. So now I have this file called matrix mean, and it's 73. I know there's an anomaly because it lost these 2 offshore near Penghu. But nonetheless, I have the 73 that are located on Taiwan. And I now have a mean distance. So that's interesting. Basically, I now know that the mean distance from each power plant to the nearest 5 railway stations is X, certain value, which is great because now I can map those. I can use graduated symbols. I can use the mean distance as my value, and I could use size. I could change these sizes a bit, make these bigger, quite a bit bigger, say from 1 to 14. I could make them equal interval, or I could make them natural breaks with a larger number of values, or maybe just quantiles. And give them some transparency with that. Okay. So now we can see, in terms of actual meters, the mean distance from each of these plants to the nearest 5 stations, which is interesting because basically you can see really clearly that there's several locations where the power plants are actually quite close to the nearest 5 stations. And there's other cases where the power plant is quite far from the nearest 5 stations. So that's what I wanted to know. It's like, where in Taiwan are there power plants quite close to railway stations? We've used the distance matrix, and we've used a join by location to get a statistical summary, a mean value, and hopefully that gives you some more tools to use in QGIS 2.10.